I do extension talks, I a lot of times get into the management strategies of fertilizer and talk about applying ammonium and nitrification and leaching and all that stuff. And every now and then I get asked about, well, what the heck's ammonium? What's nitrate? So I thought it'd be a good opportunity to go over some of the basics of nitrogen, just some of the basic science within it. One, nitrogen is essential to plants because it's involved in DNA, it's a part of proteins, it's a part of amino acids. Without nitrogen, the plants could not survive. It's also one of our 3 macronutrients, which means it's taken up in the largest quantities of all of our plant essential nutrients. Our atmosphere is made up of nitrogen. In fact, there's 78% of our atmosphere is into diatomic nitrogen. Now, unfortunately, our plants can't use that nitrogen. Our plants use 2 primary forms of nitrogen, which are NH4 or ammonium, that's ammonium ending with an M, it's a plus, and nitrate, NO3, that's a negative. Now to get from here to here, we either need some rhizobia or we need some bacteria, we need something to convert this atmospheric nitrogen into a plant usable form as ammonium or nitrate, or us as humans create nitrogen via taking a lot of heat and a lot of pressure and basically squeezing this down and turn it into ammonium form. All of our fertilizer nitrogens come from atmospheric nitrogen. Now, the importance of these 2 in the plant is that the plant can take up both ammonium and nitrate. Ammonium is non-mobile in the soil. Now, it doesn't move in the soil because the soil has a net negative charge and ammonium has a positive charge and opposites attract. So the ammonium holds onto the soil surface. So you have it going this way and it holds and binds to the soil. Unfortunately, our nitrate, which is a form that is negative, is repelled from the soil and it wants to stay away. So it stays in our soil solution and can be lost to leaching and volatilization. Many of our nitrogen forms that we use on a regular basis are ammonium-based forms. The most popular form of nitrogen is anhydrous ammonia. Now that is NH3 as a gas. NH3 is applied in the soil. It takes hydrogen out of the soil system and turns into NH4. Now this happens in a matter of seconds. And so seconds after ammonia is applied, it's turned into ammonium and it's plant usable. Now over a period of time, if there's enough moisture and enough warmth and the right amount of bacteria and microbes in the soil, we have the water plus microbes gives us NO3. So we go from a form that holds to the soil to the form that can be leached in the soil. In Oklahoma, this takes about 4 to 6 weeks. And so that's the process that we call nitrification, the turning from ammonium to nitrate. Now if you think about most of our forms of nitrogen that we apply to agriculture soils, it's ammonium based. That's anhydrous ammonia, NH3. Diammonium phosphate, that's DAP 18460. Monoammonium phosphate, that's MAP 1152O. And urea. Now urea doesn't come in as an ammonium or ammonia, but it's actually in a form that is acted upon by an enzyme called urease, and it goes from urea plus urease gives you ammonia. So it's almost like adding ammonia gas. Now, those are the basics to nitrogen, which is one of our top 3 macronutrients. It's the one that we find the most deficient in the state of Oklahoma in our cereal crops, primarily due to its ability to be lost in the system. If you want to know more about nitrogen, feel free to log on and watch some of my lectures that I give in soil fertility class. Those links are available at sunup.okstate.edu.